For 60 years, every computer chip got its power and its data from the same side, the front. This year, the most advanced chips flipped over and started taking their power from the back. Stay with me, because this one flip is what finally put Intel back ahead of TSMC, and it changes what your next node can do. Here's how we got here. Picture a chip's surface as a city where the power lines and the data roads are stacked on the same level. For decades, that worked fine. But as transistors shrank to 2 nanometers, that top level ran out of room. The fat power wires started choking the thin signal wires, and the transistors got starved of clean voltage. The thing that quietly caps how fast your chip runs. You can't fix that by shrinking more. So the industry did the one thing it had never done in the entire history of the chip. It took the finished wafer, flipped it upside down, and moved all the power wiring to the back. Signal on the front, tuned for speed. Power on the back, clean and uncrowded. Intel shipped it first, they call it PowerVia, and it buys about 6% more speed for free, the kind of gain you used to need a whole new node for. TSMC's version lands late this year. Here's the part that's yours. This idea wasn't new. Engineers wanted it for years. What was missing was the manufacturing, the part that lands on you. To put power on the back, you grind a 700 micron wafer down to about 1 micron, thinner than a red blood cell. Bond it to a carrier and hold it flat to a few nanometers across a plate the size of a dinner plate. The design was the easy part. Whoever masters the grinding, the bonding, and the metrology wins the node. That's not a design job, it's a process control job, and if it's your fab that cracks the grind and the bond, you win the node. And it's not free. Trapping the power under the chip makes the heat harder to pull out, a headache your thermal team inherits. A real trade, not a miracle. If you want the FabFlow read on where chips actually go next, you're in the right place. Now, your FabSpeak tip of the week. Stop asking AI to find the problem in your process data. Give it the detective recipe. Paste your readings into ChatGPT or Copilot's data analysis and say, treat this as SPC, set control limits from the baseline, then flag any point past 3 sigma and any run of 7 on one side, ranked by severity. I ran that on a sample thinning step log. It flagged a slow upward drift 7 readings before the hard excursion, the exact creep a human eyeballing the chart misses. That's the difference between you scrapping one wafer and scrapping a whole lot. This is FabSpeak, the view of AI and chips from inside the fab. One signal a week. Follow so you catch the next.